Okay, this is the second video for 11.3. This is the more challenging video because how I can make these questions harder for you guys is if I mix 30, 60, 90 triangles in, or special right triangles as well, into the area of segment problems. So here's an example of the most difficult type of question I could ask you is to find this area of the segment. So this isn't a sector. This is a sector. And what they did was they took a bite out of it and in the shape of a triangle. So they want to know what that leftover area is, and they call that the segment. Okay, so there are 3 steps. The first step is to find the area of the whole sector, so this whole piece of pie. So since it's talking about area, we use pi r squared. In this case, r is 9, so pi 9 squared is 81 pi. And then you have to take that whole thing, because that's the area of the whole circle, and multiply it by the degrees that they're talking about. So it's 120 degrees out of the whole 360 degrees, which is the whole circle. So we multiply that out, and it comes out to be 27 pi. So I'm going to write 27 pi here, and I'm just going to remember that that's the area of the whole pie. Okay, I'm going to erase this because we're going to need a lot of room for the second part. The second step is the most difficult part because we're talking about special right triangles. I'm going to zoom in so you can see what I'm talking about here. Okay, the second thing, we want to find out the area of this triangle so that we can subtract it from our whole area, the area of the circle. Okay, so trying to find the area of this triangle, and we know that if this arc measures 120 degrees, then this angle is 120 degrees. Okay, and we know that this side's 9 and this side's 9, but we need to know what this side is, because to find the area of a triangle, the formula is base times height divided by 2. And remember, the base and the height are perpendicular. Right now we don't have any perpendicular lines, so guess what you get to do? You get to draw a perpendicular line. And that's going to cut this into 2 congruent pieces. And let's see what else. Oh, that also splits this angle into 2 congruent angles. So instead of being 120 degrees, we now have 60 degrees and a 90 degrees, which means this is a 30 degrees. So we have a 30, 60, 90 triangle. So 30, 60, 90 triangles, remember the shortest side is always considered our 1x. The hypotenuse is always considered the 2x because it's the largest and that 2 is the biggest number. And across from the 60 is always the x radical 3. Okay, so we know that this is 9. This is the hypotenuse because it's across from the 90-degree angle. So that means that the 9 is the 2x. So to find out what x is, you just divide it by 2, and that means that the shortest side of the triangle, the one across from 30 degrees, has to be 9 divided by 2. So I'm just going to put 4.5. Okay, 4.5. So now we know that this side is 4.5, and that's going to be the height of our triangle. So for area of a triangle, we have base times height, which we just figured out was 4.5 divided by 2. Okay, so now we need to figure out what the whole base is, and to do that, we need to figure out what this part is. Well, if this is 4.5, and we already know that this side's 9, this third side has to just be 4.5 radical 3. So this one's 4.5 radical 3. And if you don't, that's special right triangles. So whatever the shortest side is, the longest side, you just multiply by radical 3. And so if this side is 4.5 radical 3, that means this side also has to be 4.5 radical 3. And to find out what the whole base is, all you have to do is add up the whole numbers. So remember, 4.5 radical 3 plus 4.5 radical 3. That's like saying 4.5x plus 4.5x. You leave the x's alone and you just look at the whole the numbers. And that's going to be 9 radical 3. So we just found out that the whole base is 9 radical 3. So that's our base. So the last thing we're going to do is figure out what the area of the triangle is. So I'm going to, again, just look at not my radicals, but my other numbers. So we have a 9 times 4.5 and then divide it by 2. Keep the radical by itself. So 9 times 4.5 is 40.5 divided by 2, and you get 20.25. So the area of this triangle that we had is 20.25 radical 3. Okay, write that down because I'm going to scroll back out and we're going to lose all this work. Okay, so, oops, thank you. Okay, so we found out, just to recap, first thing we did was found the area of the whole sector, this whole thing, and we said that that came out to be 27 pi. The second step, that was the hardest step. We used 30, 60, 90 triangle, and we found that the area of this triangle was 20.25 radical 3. The last thing you get to do is you take the area of the whole thing, 27 pi, and you take the area of that triangle and you subtract them. And depending on what your calculator is like, you can put this all into your calculator in one swell swoop. Like you don't have to, in one simple turn. You don't have to press any equal signs or close any brackets. So I get that the area of this shaded piece, once I did it in my calculator, it was 49 point, let's see, nearest hundredth, 0.75 centimeters squared, since we're talking about area. So we have to have that squared. Okay, so it's our final answer. This is the hardest type of question I can give you. And then last question you're going to try, number 3, on your notes, you are going to do this one, number 3. And again, the steps are the same. Step 1, find the area of the sector. Step 2, find the area of the triangle. And again, it's either going to be a 30, 60, 90 or a 45, 45, 90, which might be in this case. And then step 3 is to subtract the two answers. All right, so try this one tomorrow. You might see this one in your quiz. This is the hardest question I could give you about area of segments. Good luck.